All right, so this is where we left off in the last video. We're not gonna, we are gonna save this. I'll just put it in my folder so I can pick up the other one. Okay. All right, and then we're going to open up these program here for that I put together for the example for the static case. Okay, so this is the case study 1A, and it looks like a lot, but if you look through the example for the case study for 1A, what we're looking at here is this example. Okay, and over here we have these dimensions, which are these distances here: R32, R12, RB2, R31, R21, R31, RD, RP. Okay, so these are all distances that we can just measure using some calipers. Okay, so we get those distances here that are all in millimeters, and over here we've entered all of our units. So those are all the distances for those problems. These are the knowns. Okay, so we know that F13, for example, okay, F13 here, and F31, we're assuming that there's the X component is really small, F13 and F31, and then here we have this F23 here. We assume that that angle is small, but the force is not insignificant, and so we have the X component, we just say it's some F32 times the tan of theta, and we define theta as 143 degrees. So these are the parameters from that problem. Let me see if I can pull it up and maybe bring it up here a little bit smaller so we can kind of look at them side by side. Okay. All right. So this is the system that we're analyzing in it. And if we do the static analysis where we sum the forces, okay, for the brake lever, we're just summing these forces to 0. Okay, so we have these X and Y components, and then we have these moment arms, which is the force, times the perpendicular distance to that force. And if we sum the moments, we get this equation right here. Okay, so I've just entered those equations in for the brake lever. I've entered the equations here in for the cable here, and then we have our handle, which is down here. Let me make this a little bit bigger. I'll bring it up so you can see it. Okay, so this is the the handle. So we have the cable, or we have the lever, free body diagram. We sum the forces and moments. We have the cable free body diagram. We sum the forces here. We're assuming there's really no moment because it's taken about this point. And then we have the handle here, which we sum the forces here that are acting on it. We just put all these forces in. We don't know what all the internal forces are, and that's the beauty of EES. It's going to tell us what they are from what we know. As long as we have the same number of equations and unknowns, it'll solve. And as long as we didn't enter the wrong numbers, we should be good to go. So then we have these equalities where we have the equal and opposite forces between the different bodies. So this is between body 2 and 3, body 2 and 1, body 2 and 1, body 3 and 1. Okay. And the cable and the sheath forces here are equal and opposite. And then we have some assumptions here. We say that these forces FB1, okay, and FB2 are equal, and they're equal and opposite. And we say we have really no Y component from the cable, and that's because we're assuming we really don't have any frictional forces that are sufficient because we have a pretty smooth surface. Okay, so what we can do is check it. We have 41 equations and 41 variables, and we can check our units, and there's no unit problems detected. Okay, and we can look in here and make sure that we have all these equations. It's pretty easy because they list all the equations. You can go down and make sure you didn't make a mistake. One of the nice things is you can highlight variables that are only used once. Okay, so this moment, which is an unknown moment, this angle, okay, this force F23, those are the variables that are only used once. Now, if you've tried to solve problems like this in the past using MATLAB or Solver, you should quickly see that it's a lot more complicated to get what you need. In fact, the method in the book is to take all these equations and then put them in a matrix and then solve the matrix. Well, EES does it for you as long as you get your bookkeeping right. Okay, so if you get your bookkeeping right, you should get the same number of equations as unknowns. You should also, let me make these a little bit bigger. Okay, if you look at these, you can see all these equations. And another good thing about EES is you can look at the formatted equations. Okay, so you can come down here and you can actually look at your formatted equations to make sure you put the variables in at the right and double check your distances and everything like that. Okay, so it probably took me like an hour and a half to put all this in. Okay, but if you're working on a problem and you need to make sure you get stuff right, it's important, to go through the work and analysis to make sure that we got the right loads everywhere and that everything is okay. Okay, so this is just that example from the book. Okay, and then what we can do is we can run the solver. You can hit F2 or hit the calculator. Uh-oh. So we got a problem here. All right, so I had a issue here where I had the same unit twice, so I fixed that. Okay, so then we can check our units again. No unit problems are detected, which is good. 41 variables, 41 equations, and we hit solve. We got 41 equations, 13 blocks, took less than 200 milliseconds, and then we get all of our forces here. Now, the beauty of this is now I can go here to my knowns, and let's say I want to, double this or make this force 10 times as large, maybe to simulate a worst case scenario, somebody jumping off a ramp and landing hard with their wrist onto the thing, onto the handle. Then I can do that, and I can see all my loads are updated. Okay, so I highly encourage you to just get into EES, use it to solve your homeworks if you want or other problems. Make sure you use your units. It does take a little bit of getting used to. I don't claim to be an expert, but I definitely know that it's a useful tool. Another good thing as well is if you are working on a design problem and you realize you have too much load here, and let's say you need to make something bigger, well, you can go in and you can edit these variables. It's as simple as, just editing them and then running them again and then seeing what happens. Okay, so when you're working on a design, you should know what your critical components are, where the maximum loads are going to be. In this case, we have 1909. We have a moment of 9,000 and loads of like 400, and then we can see which components we think are going to fail first. So Anyway, I hope you found this example useful. This is how we use EES. And again, we basically just did our two-dimensional static analysis for our free body diagrams for a simple mechanism, which just required a little bit of bookkeeping. So we'll end the lecture here. Make sure you install EES and start to play around with it. Hope you guys have a great day.